Hello everyone, this is Hari, and today we are going to discuss about a power electronic device, and that is SCR, silicon control rectifier. And basically, power electronics is a branch of electrical engineering which deals with the power conversions like AC to AC, DC to DC, DC to AC, and AC to DC by using few devices like inductors, capacitors, and few semiconductor devices like diodes, thyristors, MOSFETs, IGBTs, etc. And the power may be from milliwatts to megawatts. We can use loads from milliwatts to megawatts. And power electronics is the center of all the branches. If we need to combine any two fields, and that can be done by using power electronics mainly. Okay. And coming to SCR, it is a thyristor family device, and basically it is called as a thyristor, and it is developed in 1957. And the name silicon control rectifier is given by General Electrical Company, and it is a trade name for a type of thyristor. And basically, power semiconductor devices are broadly classified into three types: power devices, transistors, and thyristors. So SCR is a thyristor family device. It consists of 4 layers and 3 junctions, and the 4 layers are P, N, P, N, and it is a switching device. It has 3 terminals, namely anode, cathode, gate, and SCR is a solid state device. So it is compact, very easy to use, it has high reliability, and it has low losses. And SCR is made up of silicon, and it is a control device. So hence the name silicon control, and it can be act like a rectifier. So the name silicon control rectifier, it has low resistance, very low resistance in forward direction, and offers very high resistance in reverse direction, and it is a unidirectional device. And coming to the symbol, this is the symbol for SCR. It consists of 3 terminals: anode, cathode, and gate. And coming to the constructions, so this is a construction of SCR. It has 3 terminals: anode terminal, that is positive terminal, cathode terminal, negative terminal, and the gate terminal. So this is gate terminal, and it forms by connecting 4 PN layers. These are 4 semiconductor material layers which can be joined in the form of NPNP or PNPN. In PNPN type structure, anode terminal is connected to P layer, cathode terminal is connected to N layer, and the gate terminal is taken at P layer, which is nearer to the cathode terminal. Okay, and the semiconductor material layers are formed by diffusion of lightly doped semiconductor material into highly doped semiconductor material. Okay, and coming to the working, SCR works in 3 modes. That is reverse blocking mode, in which the SCR is connected in reverse bias and it blocks the current. And second one is forward blocking mode, in which the SCR is connected in forward bias but it blocks the current. And forward conduction mode, in which the SCR is connected in forward bias and it conducts the current. First one, reverse blocking mode. So this is SCR, it has 4 layers, P, N, P, N, and this is gate terminal. And if the anode terminal is connected to the negative terminal of the supply with respect to cathode, or when the cathode of the thyristor is made positive with respect to anode, then the SCR is said to be in reverse bias. And in this mode, the switch is in open state. So now anode is connected to negative terminal and the cathode is connected to positive terminal, and the gate is kept open. So now the junctions J1, J2, J3, these three are the junction, And the J1 junction is formed by these two layers Pn, and J2 is formed by these two Np, and J3 is formed by these two Pn. So these three are the junctions which are also connected to this supply. Now coming to the junction 1, in this junction 1, P is connected to negative and N is connected towards positive. So it is reverse biased. In the same way, for junction J2, N is connected to negative and P is connected to positive. So this is forward biased. And for junction G3, P is connected towards negative terminal of the supply and N is connected towards positive terminal of the supply. So here junction J1 and J3 are in reverse bias and junction J2 is in forward bias. So as these junctions J1 and J2 are in reverse bias, this SCR does not conduct any current. And a very small amount of leakage current in the range of very milliamperes only flows, and that is known as leakage current. So as it is connected in reverse bias and it is blocking the current, the mode is said to be reverse blocking mode. In order to conduct the current, all these three junctions should be in forward bias. As in this mode, only junction J2 is in forward bias and junction J1 and J3 are in reverse bias. SCR does not conduct any current. And if we increase this voltage further beyond the reverse breakdown voltage, a avalanche occurs at this junction J1 and J3. So because of this reason, the current increases rapidly and very large current flows through this SCR. And this damages the SCR, and the temperature across these junctions also exceeds the maximum temperature. So that is not safe. Next, forward blocking mode. In this forward blocking mode, SCR is conducted in forward bias, which means that anode is positive with respect to cathode. Means anode terminal is connected to positive of the supply and cathode is connected to negative of the supply, and gate terminal is kept open. So in this, the three junctions J1, J2, J3, in junction J1, P is connected towards positive and N is connected towards negative. So it is in forward bias. And for junction J2, N is connected to positive and P is connected to negative. So this is reverse bias. And for junction J3, P is connected towards positive and N is connected towards negative. So this is also in forward bias. So junction J1 and J3 are in forward bias and junction J2 in reverse bias. So as this is in reverse bias, it does not allow current. So this is also blocking the current. So hence the name blocking mode, and it is connected in forward bias. So it is called as forward blocking mode. As this forward voltage increases further beyond the breakdown voltage, avalanche breakdown occurs at this junction J2, and that voltage is known as forward breaker voltage. And when the forward voltage is less than the breaker voltage, this SCR offers very high impedance, which means that it acts like a open circuit. So this is forward blocking mode. Next, reverse forward connection mode. Sorry, forward connection mode. So the connection is same as that of the forward blocking mode. Anode is connected to positive with respect to cathode. And in this mode, the thyristor conducts current from anode to cathode with a very small voltage drop across it. And this can be done by using two methods. One is by exceeding the forward breaker voltage, and the other one is by applying a gate pulse between gate and cathode. So this is a gate supply. In the first case, the increase in applied bias voltage more than forward breaker voltage, then this, as we all know that junction J1 and J3 are already in forward biased in forward connection mode, and the only junction J2 is in reverse bias. So if the voltage is increased beyond the breakover voltage, a breakdown occurs at this junction J2. This results in the sudden increase in the current flow from anode to cathode. So current flows from anode to cathode. And the second case is that without increasing this forward bias, forward breaker voltage also, we can turn on the SCR by giving gate pulses. So very small amount of gate pulses can turn on the SCR. And in this forward connection mode, the SCR acts like a switch, closed switch, and the voltage drop is very low and SCR conducts. So as this is in forward bias and it is conducting, it is known as forward conduction mode. So we'll see the characteristics in the next video.